Hello again, everybody. This is Michael, K4EST. And we're back here with the HeathKit audio generator. Model IG-72 to be exact. And I've done a few things to it since then. So, let's go through it. Let me see, I can take this. Take the oscilloscope probe loose for a minute. And, well, let's see. Let's start. A little dust on it already. Up here. And we'll start right in here. Alright, first thing, well, not necessarily the first thing I did, was I went through it. I'll go ahead and I replaced this control here. You know, your output control. It was kind of finicky. I took it apart and cleaned it, and still just kind of was giving me some weirdness. So after a second cleaning, I just replaced it. Seems like it has 600. No. This one's exact replacement. This one here was an exact replacement. So replaced that. Cleaned up the other two little, well, you can't see them for the tubes, can you? The two other little potentiometers here for the meter calibration and for the oscillator calibration. The indicator light was fine, so didn't have to do anything to that. Cleaned it all up. As you can see, if you look at the other video, how rusty and everything the transformer was. Now, here, I did replace, like I said, these three capacitors here. Put in 3 new ones. These are excellent capacitors, by the way. Illinois Capacitor Company. And then I wasn't going to replace the micas, but this one here was, again, being when you was in this position over here. What is that, like around the times 100 position? Kind of strange there too. It was almost looked like a double sine wave thing going on. So replaced that, and it didn't change. So I just left it changed out there. We'll get into that in a minute. And then also, I think in the last video I said this up here is metal on metal, which it's not. Oops, sorry about that. It's not. This is got that Bakelite or whatever that is there. Probably Bakelite. I still tightened it up. It was really floppy around, but you can see now I'm really having to push it to get it to move. Tighten the transformer up. Checked all the tubes. They were all good. The 6AU6, and I think I called this 6AU5 in the other video. The 6AU6 was a little bit weak, so replaced that. Got that done. This here is a kind of a temporary thing. I've got to go back in here and put a like I did here with the rivets when I put that big power resistor in there. Front, I popped this off, got that straightened out so it ain't full of static in there. Made sure this was adjusted. Cleaned it up a little bit. Let's back that up a little bit like that. Yeah, let's see, cleaned it up. It's a little shinier. It's not perfect. I left some of the, stuff on it, and you'll try to paint and touch up any of this stuff because, it's fine. I'm not going to set this on the shelf for looks. It'll be half looks, half being used, because I do have a couple of modern solid state audio generators and things like that, but I just think it's really neat to go in and be able to take one of these, hook it up, and use it. I just think that's so neat. And I love going through this stuff and refurbishing this stuff and getting it back going. And you kind of want to clean it up, but sometimes you want to go really good because there's places you can buy where they've matched these paints. There's a couple people online that sells the exact paint to match this, and the paint to match the light gray and the dark gray. You know, for not just HeathKit, but Hallicrafters and a couple of other radios and test equipment gear out there. But there's a few dings here and there and little nicks, and that's okay. I'll just leave that. Alright, let's flip it up here and show you what I did. We'll start here at the top and zoom in just a little. Whoop, not too much. Back it off just a hair here. Okay. You can see where I had these out. You see that? Yeah, you can see that loose wire. Okay, I'll get to that in a minute. That power resistor that was here, like I said, took it, put a 5K in, and mounted it to the back there. Little heatsink compound. Put that there. Replaced that capacitor. Checked all the resistors and stuff, and everything's pretty good. Took these and cleaned them. You can see I've had them out and resoldered them. If you can tell that in the camera, it's a little brighter there. What else? Let's come down. This capacitor here, remember they was one I took it out. It was, you know, I really don't know. I mean, it looked like a good one and a newer one, and it was probably fine, but I don't know the history of it, so I just replaced it. But it was going like, what, over through here somewhere and just kind of hanging in midair. I remember it had the heat shrink on it and all that, but I just moved it over here and replaced it. Kind of went around like that and worked out really good. Let's see, sort of, kind of, maybe. Yeah, there we go. We can see one of them anyway down in there. But safety capacitors across the line cord. There's two of them in there. I did leave that fuse for now. I just left it. You know, if it eventually does get tired and goes out, then I'll worry about that then. The 3-watt light was good, and then I replaced the capacitors in the power supply here. Put a meter on this, and I was getting 440 volts, 440, 442, something like that, and the capacitors was rated 450 volts. It's like a lot of these I have. I've got several of these, you know, new in the drawer, and they're 450 volts. I had the exact one for this. What was it, 40? And I think, well, see, I had 50s that I could have put in there, but man, it was just pushing it. So what I did, you can see that there. Should be able to kind of see that down in there. I've took two and series them up, and took two more and series them up, and then went out that way, and that's what I did. They're 100 microfarad capacitors at 450 volts, so that gives us 900 volts at 50 microfarad. Because when you series up capacitance, you know, is, well, if they're, let's just put it this way, if they're equal capacitance, it'll be half. You know, if there's 200 in series, it'll be 50. If there's 280 in series, it'll be 40. If they're not equal, then you gotta do some math. And also, it increases your voltage rate. So 450 and 450. Now, you know, I'm dropping 200 some volts across each capacitor instead of 440 something. So I did that. That's about it, I think. Went through everything, like I said. You can see where I left in the original can capacitor. I didn't try to restuff it or anything. I just cut it out. It's tucked back up in there. Should be able to see that. It's just clipped off and shoved back up in there. But anyway, I put it on the scope. Got all this done, and well, you know, a couple of things I did. You know, of course, I fixed this, changed the capacitors, put this in. Seems like I did one other thing, and then I fired it up for the first time since I've had it. Get that back out again. Everybody can't see what I'm doing here. Fired it up, and I was getting, like I was saying, this funny double. The oscilloscope pattern was like blurred vision type thing going on, and you get two traces really close to each other. It's kind of wobbling back and forth, you know, and they're just. And of course, this is going to have a little bit of wobble in it. If you knock the unit, reach and smack it, you know, around, or if you, when you flipping switches on the front and click it, you'll get a little bit in it because of the Wien bridge oscillator. You know, the filament in here kind of moves just ever so slightly, and you'll get that. But it shouldn't be looking like that. So I went through this thing. I thought, well, maybe got a bad resistor I'm not, you know, catching or something. And I've got a Mr. Carlson's Lab super probe that I built. If you're not familiar with that, if you're not familiar with Mr. Carlson's Lab, then you need to go check that out. Look on YouTube for Mr. Carlson's Lab, and great channel. I'm not a spokesperson for his channel or anything, but awesome channel. It makes me look like, you know, I'm a baby in this stuff, with the videos he's got and the stuff he does. But I built one of his super probes. He had one of his videos. I'm running it all around in here, trying to, you know, I can get close to the oscillator and hear the oscillator, but you know, couldn't find any pop in or whatever. So I'm still getting the signal. I'm like, it's making no sense. This is not nothing modern with a bunch of chips in it, and something could be going crazy or something. So I'm like, something, you know. I even changed out tubes, thinking, well, the tube's showing strong, but sometimes there can be something going on in the tube that the tube tester's not showing or something. It's trying to break into oscillation, maybe in this circuit, but it ain't going to show it in the tube tester circuit. And then I'm going through it, and I'm looking, checking all the connections, solder joints, and then I'm looking, and I don't know if we can get this on camera good. Here's this loose wire. It's got it sticking out there. It was tying in to right here. That's the oscillator adjustment, you know, where when you're calibrating the oscillator. It was soldered right there. And then it goes all the way back down in here. I'm going to take this out, but I left it in here for the video. I'll take this out and I put the case back on it and put it over there to use it. Way off down into here. And tied to ground. Which this is a ground. This center is supposedly tied to ground. Oh, there we go. I've got the camera back down there. The center is supposed to be tied to ground. Oh, wrong schematic. Yeah, I got a better. It's laying right here. I'm getting ready to shoot a video. So here's your output control here. That's on the front. And there's that oscillator control, and you can see the center and one side, you know, it's tied to ground. Very commonly done. Okay. And then this is going to the lamp here. There's the little 3-watt bulb in there. But this wire was attached right there to that center. And just going down in there. Way off over here and grounded. And I do not understand that. And if I sound a little bit hoarse, this pollen this time of year is getting me. And I apologize for that. But I don't know, you know, why somebody did that, what that was for. I didn't, you know, I was looking through the book, and I don't know what the point of that was. But this somehow is causing a ground loop. Okay? And causing it to do craziness. So anyway, let's hook this back up here. Whoop. Be back at ground. Set it down. Okay. Let's go ahead and move this light. Let's go ahead and focus on the oscilloscope. If I can get that. It looks a little crooked, but it'll work. Alright. Let me reach over here and turn on the oscillation transformer and variac. Alright. And we'll turn on the audio generator. Alright, we'll let them tubes start warming up. And there we go. There it goes. Okay. Let's see here. And that's supposed to be 1 kilohertz. We are reading, I don't know if you can see that on the camera, but the little frequency on the oscilloscope saying 1.10982 kilohertz. So 1.1, almost 1.11 kilohertz. And I'm just double checking here to make sure, yeah, that should be 1 kilohertz. That's the only thing with this type of audio generator. They, made better ones, of course, that were tube. With this one, you have to go in and do some resistor changes. If the one's got a variable capacitor in it, you can go in and, put some padding on the capacitor, or tweak the capacitor, or whatever. A lot of times, have a trimmer on the capacitor to try to trim that in and get it closer to what it's supposed to be. But you can see you can vary it up and down, and it's nothing. We're back here. But I mean, for what it is, this is a pretty good little, it's close enough. It's a good little audio generator for something where it ain't gotta be exact. If you need that, especially in this day and time, it's time to bring out the solid state stuff. Just be honest with you, if I'm trying to line up something or work on a radio or whatever, time to bring out the good stuff. But as long as it's not anything, it's got to be perfect, and I just need 1000 kilohertz tone, or whatever. You can bring that down. Let's say I'm wanting to do a 600 kilohertz tone, and that's 665. Well, it's close enough, right? Close enough, right? For most things, if you're just needing to inject an audio signal into something, if you're going through a alignment procedure on something that says inject a 700 hertz tone, well, there is it's 776. And if you want to get a little bit better, you could put this on, put it back on 600. Let me show you what I'm doing here. Zoom back out. It's not quite centered up with the camera, but you got this here is 0 to 100, and then you got your multiplier. I'm on times 10, so I'm on 60 times 10. It's supposed to be 600. And then you got this over here, 0 to 10. So this should be 610. This should be 620. But I can do this too if I kind of know what's going on. So that right there's 708. It's supposed to be 640, but I'm getting 708. So that'll give me, if I kind of know what familiar with it, and I want to get a little bit closer, I can do that. But like I say, if it's something that needs to be way more accurate for whatever reason, and let's be honest, most of the time you're not going to need nothing super accurate when you're doing something down the audio frequencies like this. Now when it comes to RF and stuff, yeah, that's a whole different ball game, but this is just fine. And that's the only thing about this too is you've got these preset kind of things here. I can't go, well, if this is not like a variable capacitor where I can just kind of tune it, it's click 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 click. I can't just kind of tune it and say put a frequency counter on it to get it right. If I still wanted to use this, I still want to use this. I want to be a diehard and use a tube, audio generator, but it's got to be exactly 700.000 or really close to. So I can put the frequency counter on and adjust this to get it right as close as I can. Of course, I have to make sure the case is on it and it's warmed up, for at least a good 30 minutes or longer is even better. But, that'll be fine. But now this can go over there with the laboratory generator and set up there. And it can look pretty, but I'm going to have it set up where I can use it too. I need a quick, audio, well, not super quick because I gotta let the tubes warm up at least a few, you know, a minute or so. Well, not quite that long, but I'm gonna use this, you know, just for the neatness of it, the nostalgia of it. Just to me, it's cool. Fire this thing, getting the tubes light up, even though I can't see them, but I know it's got tubes in it, and I'm adjusting it and doing whatever. So anyway, this has been calibrated. If you get one of these, you can go online, download a manual. It tells you how to calibrate everything, calibrate the meter. So if I had this hooked up here, this is RMS voltage, I hooked up to my voltmeter, and I got it adjusted so that these match exactly. When this says 6 volts, that's saying 6 volts, you know, over there on the meter. So anyway, there's that. It was fun going through it, just like any of them. Even if it's a small little thing that's got 1 tube in it, or something that's got 20 tubes in it, it's always fun to go through, get everything, and just bring it back to the way it was, you know, back in 1960 or 1940 or 1970 or whatever. So anyway, and you can see we're still holding pretty steady. Zoom in there a little bit. Pretty steady. 708 still. Well, no, as soon as I said that, look at it. See, I can tap the table. You see that? You see that? How I can just bump it. You know, it's the Wayne Bridge oscillator. But anyway, I hope shut that off. Hope you enjoyed this, and hope it helped somebody out. And if you have any questions or comments, please post them in the comment section below. If you like this video and it helped you out or whatever, just don't forget that like button. If you're not a subscriber yet, there's plenty of videos like this and other things coming along, and there's other ones you can watch. So don't forget to subscribe and share it with somebody else. And until the next video, this is Michael, KE4EST 73.